Hi, my name is Darshan and I'm an online tutor of math and physics. This is the first question, first FRQ of 2023 Calculus BC exam. This is part A, so the calculator is allowed. Let's start. Let's start working on this question. This is based on integral calculus, application of integration. It says that there is a customer at a gas station who is pumping gasoline into a gas tank. All right, and the rate of flow of the gasoline is modeled by a differentiable function f, where f is measured in gallons per second. So this is important, that f in itself is actually the rate at which the gallon is pumped into the tank. So I'm going to highlight this part. And t is measured in seconds. Fair enough, t is measured in seconds since the pumping began. Selected values of the function ft is given in the table. So here we are given a table where the value of ft is given for some values of t. Using correct units, interpret the meaning of this guy. In the context of the problem, use a right and Riemann sum with 3 subinterval this to approximate the value of this integral. All right. So first off, what are the correct units of this guy? I'll tell you a very easy way to find the units. Notice this ft. What is the unit of ft? That is gallons per second, correct? Gallon or gallons per second. So per second would definitely means that we divide this with seconds, so per second. And then you multiply with dt. What is the unit of dt? dt is nothing but time, right? And what is the unit of time? That's seconds. These two are gone, you're just left with gallons, which perfectly makes sense because the integral of gallons per second, so integral of a derivative is going to give you that function itself, right? So it's going to eventually give you gallons, and we have sort of proved it mathematically as well. So the unit of whatever we get is gallons. So this is something which we have proved. And now, in fact, let me keep this as it is. And now we are going to use the right and Riemann sum. Fair enough. What is the difference, or what is the rectangle's width of the Riemann? So 90 minus 60 is 30. 120 minus 90 is 30. But here it's not 30, right? Be careful. It's 15 units. So that's fine. Where there are three subintervals, so we just have to find the area of each of the rectangle, right? So the integral from 60 to 135 ft dt, okay, we are going to interpret the meaning of it as well once we find the value. This is going to look like the area of the first rectangle, which is going to be the width, which is 30, multiplied by its height, right? And what is its height? Its height is going to be f of 90, because we are talking about the right and Riemann, plus once again 30 times f of 120 because of the same reason. And in this case, we will have 15 times f of 135, once again because it's right and Riemann. It's all a matter of plugging in the numbers. So we need 90, 120 and 135, all of which are given in the table. So 30 times 0.15 plus 30 times 0.1 plus 15 times 0.05. All right, calculator is allowed. So let me just grab my calculator. You can fast forward this this particular section of the video. Plus 3 plus 15 times 0.05. That's going to be 8.25. This is what I'm getting, 8.25. And what is 8.25? We already defined that, right? This should be gallons. So this is 8.25 gallons. And what is the meaning of this? It means that between 60 and 135 seconds. Why 60 and 135? Because notice these limits. The lower limit is 60 and the upper limit is 135. So between 60 and 135 seconds, I'm going to write the interpretation over here, that between 60 and 135 second, gallons pumped into the tank is equal to 8.25. This will be the significance or meaning of actually what we got as the answer. All right, okay, so this makes perfect sense. I hope so. Let's move on to question number 2. Now they're asking that must there exist a value of c for c between 60 and 120 such that f prime c is 0? Justify your answer. This is a classic case of Rolle's theorem. Actually, I need this table once again, so I'm going to borrow this from this page and paste it right here. Okay, it's already given in the question. I'm going back again to highlight something. It's already highlighted, it's already given in the question that f is a differentiable function. And if f is differentiable, by default, it means that f is continuous. So I know that f is continuous. I know that f is differentiable, and on the top of it, f of 60 is equal to f of 120. It's evident, right? It's intuitive. Both have a value of 0.1, f of 60 and f of 120. And don't you think this is a classic condition of Rolle's theorem? Rolle's theorem. Let's remind ourselves what is Rolle's theorem? Rolle's theorem says that if a function is continuous, a function is differentiable, and fa is equal to fb, where a and b are some values, then there exists at least one value of c between a and b such that f prime c is 0. In this case, the value of a is 60 and the value of b is 120. So there exists at least one value of c such that f prime c is 0, where c is between 60 and 120. So this is how we can justify. They ask us to justify, and this is how we are justifying that the Rolle's theorem is applicable, and using Rolle's theorem, this must be true actually. Right, I hope it makes sense. Let's talk about the next question. The rate of flow of gasoline in gallons per second can also be found by this particular model. So they have given a function that, okay, the rate of gasoline is also given by this. Using this model, find the average rate of flow of gasoline. Average rate of flow of gasoline over the time interval 0 to 150, and show the setup of your calculation. Let's ask ourselves, what is the value of the what is the expression for the average value of any function fx? So average value of fx between any two values, let's call it a to b, is nothing but the integral of fx over b minus a. That is a very simple formula for the average value of a function between a and b. Right, as simple as we are going to use this, plug this in into the calculator and get our answer. So in this case, I believe the function is t over 500 cos of t over 120 square. This should be integrated between 0 to 150 because the limits are already given in the question. There you go. Obviously there comes a dt here over the upper bound, which is 150, minus the lower bound, which is 0. We just have to plug this into the calculator, so bear with me. I'm gonna use my calculator and find this up. Please skip or fast forward this portion. It's gonna take about 1 minute for me to find, and once I do that, I'm gonna put the calculation as well for you to check. So it's t over 500 cos of t over 120 whole square dt over 150 over 150. I have to make sure that my it's in radian, so it is indeed in radian mode. So the answer which we are getting is so I think I found the answer. Let me just pull this up. Okay, this is what I'm getting. Just want to make sure that I've not messed up anywhere. 0 to 150 t over 500 cos of t over 120 whole square and dt divided by 150. So I think everything is in place. So I'm getting 0.067 7 up to 4 decimal places. Use this model, find the average value. So this is the average value, the rate of the flow of gasoline. Yes, average rate of flow. This is the average rate of flow of gasoline. So obviously the unit is going to be gallons per second. This is going to be the unit. So this is how we solve it. And the last part is using the model G defined in part C, find the value of G prime 120 and interpret the meaning. Okay. So it's as simple as you just have to find the derivative of this particular function at t equal to 140. So that should not be a problem for us because that's calculator, the calculator intensive question. I'm just gonna go back and put the find the derivative of this guy and plug in 140 in it. So give me just 1 minute. All right. Once again, I'm going to show my calculation, of course. So let's do away with this. This is G of t, and I need the value of G prime 140. So this is what I am getting. This is the value of GT over 500 cos of t over 120 whole square. So this is G prime 120. Let me just pull the screenshot up on the board. So this is what I'm getting. This is GT t over 120 t over 500 cos of t over 120 whole square. G prime 140 is what we have here. So the value of G prime 140 is going to be negative 0.00138. What is the unit of it? Remember that we are finding the derivative of something which was already giving a change. So it was gallon per second, and we are again finding a derivative with respect to time. So it will be gallon per second square. And how will we interpret this? We'll interpret by saying that the rate of flow of gasoline is decreasing. In fact, I should start my explanation with at t equal to 140 seconds, because that's where we are solving, right? So at 140 seconds, the rate of flow of gasoline is decreasing at the rate of negative 0.00138 gallon per second square. So this should be the answer for our part D. I think this was the last part for this question. Please let me know in the comment section if you feel like you're getting a different answer, if I have messed up the calculation somewhere. This is FRQ number 2 of AP Calculus BC 2023 exam. It's based on particle motion in a plane, so X and Y both are changing over here. It's not a straight line. Let's read the question. For 0 to pi time, a particle is moving along the curve shown, so its position at particular time, X and Y positions are given by this particular graph, where X is not explicitly given and Yt is 2 sine t. All right, okay, Yt is 2 sine t, so that makes perfect sense. X is not defined in terms of t, but Y is defined in terms of t. That's what they want to say. And it is known that dx over dt is e raised to cos t. So the change of the value of X with respect to time is given. X is not given, or the rate of change of X is given. And at t equal to 0, the particle is at the position 1, 0. So its X coordinate is 1 and the Y coordinate is 0, which is pretty evident from the graph as well. First question is, find the acceleration vector of the particle at time t equal to 1 and show the step of your calculation. All right, okay, we know that the acceleration, and remember, we need to find the acceleration vector. So there will be an acceleration in the X direction and in the Y direction as well. For the acceleration in the X direction, a sub X, It is going to be x double prime t, because that's the double derivative of the position, right? The single derivative is the velocity and the double derivative is the acceleration. So it's double derivative. Fortunately, we are already given the first derivative of x, which is e raised to cos t. So our aim is to find the derivative of e raised to cos t once again. So we are looking for d over dt of e raised to cos t, and that too we need that value at t equal to 1, right? So we need this at t equal to 1. We won't make the effort of doing this manually because the calculator is allowed. So we get some value which we'll find, and the value of ay will be given as the double derivative of the y function, of course. So it will be d square over dt square of the y function, and the y function is already given to us as 2 sine t. So this comes over here as 2 sine t. And once again, we need this value at t equal to 1. So all we need to do is go in the calculator section and find this up. Give me about 1 minute to find these things. Feel free to fast forward. I'm going to take a screenshot anyway and put it on the board so that you can also see what I've done. So x is e raised to cos t, and the value of dx over dt, that's what we are looking for. So let's call it fx, and this is f prime 1, right? F prime 1, that's what we are looking for. So this is x, so we got the value of f prime 1. And likewise, what is x? I will just tell you just in a minute. This is 2 sine, and we are looking for g double prime of 1, which is also something which we have. So this is my calculation. Let me just take a screenshot and pull that right in front of the board so that you can also see. Okay, so this is what I did. We needed all right, I think this is a good position. Yeah. Okay, so what we needed was the first derivative of e raised to cos t at t equal to 1. So this is e raised to cos. It doesn't matter whether we have x or t, the variable is irrelevant. We have to find the first derivative. So I did f prime of 1. So first derivative at 1, which is this is ax. And then I need I wanted to take the second derivative of 2 sine t, so it's 2 sine, and at 1, so it will be g double prime, so second derivative at 1, so I got this as ay. So the acceleration is going to be negative 1.44 and negative 1.68. So I'm going to write that the acceleration vector in the vector form is going to be negative 1.44 comma negative 1.68, either like this, or if you are a big fan of I hat and j hat, you can also write like that. So we can also say that, or the acceleration is negative 1.44 I hat minus negative 1.68 j hat. Both are acceptable answers, so there is no right or wrong answer, both are correct. But make sure we write that in vector form because they are clearly asking the vector form over here. All right. All right, this is the first question of first part of question number 2. The second part is asking that for t equal to 0 to pi, find the first time t at which the speed of the particle is 1.5. Let's ask ourselves, what is the formula for the speed? The speed of the particle is the absolute value of the velocity function and is given by root of, what is the root of speed in the velocity in the x direction square plus velocity in the y direction square? A very straightforward formula. What is the value of Vx? Vx is the first derivative of the position function in x. So it will be x prime t whole square plus y prime, likewise y prime t whole square. All right. Remember that we are already given the value of x prime t, right? X prime t is right here. It's e raised to cos t. So I'm going to plug that in over here, e raised to cos t whole square, and then I need the value of y prime t. I'm already given y, which is 2 sine t. So y is given 2 sine t. Y prime is very easy to find because that is going to be just 2 cos t. So this is how we write 2 cos t whole square over here, and then we take the square root. And remember that we need to solve this such that the speed should be 1.5. So the left side should be 1.5, and we need the first instant when this happens, right? Obviously there will be various values of t when this happens, but they are looking that when this happens for the first time. So I'm going to go ahead and use, of course, the graphical calculator. We cannot do it manually, of course. So that's going to be root of e raised to cos x, because I'm using the variable of x, plus 2 cos x whole square. Make sure your calculator is in radian mode, because if it's in degree mode, you're going to get an entirely incorrect answer. Please make sure you do that. I have ensured that it is in degree mode, my calculator, so I think I'm going to get the correct answer. All right, so the first time which I'm getting from here is, okay, I'm getting 1.254, and I'm gonna now pull that up so that you can also see. Okay, I'll explain what I did. Okay, I will explain like this, then I will move around. Okay, so what I did is I basically graphed the function which we had. Okay, I think, yeah. So this is the function which we had, e raised to cos x whole square plus 2 cos x whole square, and I just brought this 1.5 over on the other side, so it became minus 1.5. And basically we are looking for the points where it intersects the x-axis, because that will be its roots, and the first point where it intersects the x-axis is 1.254. And that is the reason why I got 1.254. If you're using the TI calculators, then obviously there will be a different way in which you get the answer, but it doesn't matter, you're going to get the same answer. So this is 1.254. I'm going to move this down. So 1.254 is my answer, which I'm going to write over here. 1.254 is the first instant at which the first time at which this the speed of the particle becomes 1.5 units. I hope this makes sense. Let's move ahead to the next question. Find the slope of the line tangent to the path of the particle at t equal to 1. That's an interesting question. Find the x-coordinate of the position of the particle at time t equal to 1. Should have worked. That leads to your answers. Slope of the line tangent to the path is nothing but rise over run, right? So the slope is nothing but the rise, which is y, dy, over the run, which is dx. But we don't know the relation of y with respect to x, which is absolutely fine, because we are going to manipulate this now to write. Can we write it as dy over dt over dx over dt? Absolutely, because I just divided the numerator and denominator by dt, right? So that's going to look like dy over dt over dx over dt. This is what we had, and the value of y, the function y is nothing but 2 sine t. So we know that the derivative of 2 sine t is just 2 cos t. So dy over dt is going to be 2 cos t. So I'm going to put that over here. This will be 2 cos t, and the dx over dt is already given to us, that is e raised to cos t in the question. So I'm going to put e raised to cos t over here, and this we need to find at t equal to 1, of course. Remember, cos 1 we do not know. We got to find the value of cos of 1 by plugging this into the calculator. So let me plug this in. 2 cos 1. Once again, please make sure that your calculator is in radian modes, otherwise you're going to get incorrect answer. So I'm getting 0.62. okay, I'm going to pull this up in front of you. Okay, this is what I'm getting. 0.62 0.6295. So this is the slope, which is 0.6295. Are they asking something? Find the slope of the tangent to the line. I think that's it. They're asking the x coordinate. The next part is they're asking what is the x coordinate of the position of the particle at t equal to 1. So they're asking the value of x, right? Okay, that's interesting. Let me try to make some space over here so that I can do the other part. All right, that's good. Okay, so if you want to find the value of the x coordinate, and remember that we are not given the function of x, we are only given the derivative. And what is the derivative of x, by the way? X prime is e raised to cos t. So that's fine. We can just take the antiderivative now on both the sides from 0 to 1, because we need to find the value of x as 1. And one very important thing is given to us that excuse me, at t equal to 0, the x coordinate of the particle is 1. So its initial condition is given to us, which we are going to use in the antiderivative as a definite integral to find the value of the value of x at t equal to 1. So I'm going to put the antiderivative integral sign on both the sides, and that too from 0 to 1 of x prime dt. And this is going to be e raised to cos t dt once again from 0 to 1. Yeah. If we integrate x prime, I'm just going to get x. And if I put the upper limit, that's going to be the x at 1 minus the x at 0. And this guy, of course, I'm going to go back and solve this using a calculator. So e raised to cos x, e raised to cos x dx, integral within the limits of 0 to 1. Okay, this is what I am getting. I'll just pull that in front of you. This is what I am getting over here. I'll just put it perhaps, shrink the size over here. This is what I'm getting as 2.34. From 0 to 1. So this is 2.34, and the value of x0, like I already said, is 1. So the value of x1 minus 1 is 2.34, and all we have to do is just add 1 both the sides. So if you add 1 both the sides, obviously you're going to end up with 3.34 as the value of x of 1. Do they need units? I don't think so, but if they have given the units anywhere, we can. I don't see units anywhere. The miles, meters. Nope, 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 nope. No units are given. So x1 is 3.34. We're going to leave it like this. That's the final answer for both the subparts given in part C. Alright, the last question is find the total distance traveled by the particle from 0 to pi. Remember, this is a direct formula. We should know this formula, that the value of the distance, the expression for the distance in the case of a plane curve, not a straight line, plane curve, is nothing but the integration of the speed from whatever points, between whichever points we need. So that's going to be 0 to pi, and remember we already have the expression for speed. We are not going to do it again. We're just going to borrow it from here, right? This is the expression for the speed. So I'm going to borrow this and paste it right here. This is what I'm looking for, and this is what I need to integrate from 0 to pi. Right, that's going to be my answer. So let me just go back once again to my calculator and get this value. I have a square root. That's a pretty big expression. It's going to take at least 1 minute for me to plug that in. E raised to cos x. Once again, please make sure that your calculator is in radian mode. We don't want to make that mistake, make that small mistake and get our complete answer incorrect. And the integral limits are from 0 to pi. 0 to pi, right? So this value comes out as, oops, I missed something, square. All right. So the value which I'm getting here is 6.03. That's what I'm getting. I'm going to pull my work front of you so that you can also see. This is what I did, just plug that into the calculator. So I'm getting 6.03. Once again, I don't think so we have units, so this is my unitless answer. Whatever units is of the distance, that's going to be my answer. All right, I hope this makes sense. This was the second question. If you have your answers different of any of the question, please comment and we can discuss. Maybe I have messed up somewhere, or maybe you have, so I can help you in figuring out where you what correction you have to make to get the correct answer. FRQ number 3. So this is part B of AP Calculus BC 2023. Calculator is not allowed. That's an interesting thing. The first question is based on slope field and differential equation. So let's read this out. Okay, says that a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at time t, where mt is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. All right, okay, makes sense. M satisfies the differential equation. So this is the differential equation, not the m, right? This is the rate at which the temperature of the the milk is changing with respect to time. So dm over dt is 1/4 of 40 minus m. At t equal to 0, the temperature of the milk is 5, and it can be shown that m is less than 40 for all values of t. So this is something which is given in the question, of course, that m is always less than 40 for all t. The slope field for this guy is shown. So this is the slope field, and we need to find the solution curve through the point 0, 5, which is right over here. That's pretty straightforward. You just have to track the slope field right carefully, and obviously it makes absolute sense that there is an asymptote at y equal to 40, because this can never reach 40, right? It's like just taper about 40. So it's gonna go like this. It's just gonna follow the track. So it goes like this, slows down and almost tapers like this over here about m equal to 40. This is obviously 40, which makes perfect sense. Yeah, so this is how the slope field is going to look like. That's pretty straightforward, right? Okay, all right. The next one is use the tangent line approximation, or the tangent or the line tangent to the graph of m at t equal to 0 to approximate the value of m of 2, the temperature of the milk at t equal to 2 minutes. So this is the linear approximation, tangent approximation, known by a couple of names. But all we have to do is find the equation of the tangent at t equal to 0, and we very well know that at t equal to 0 the value of m is 5, right? Because the 0, 5 is a point on it. So at t equal to 0, we very well know that the value of m is 5. So this is the so-called point. We need to get the value of m prime 0, or maybe dm over dt at this particular point. So we know that dm over dt is right here in front of us. That is 1/4 of 40 minus m. And what is the value of m? It's 5. So I'm going to plug in 5 here. So that's going to look like 40 minus 5, and there's a 1/4 already outside. So that's going to look like 1/4 of 35, or maybe 35 over 4. So we got the slope, we have the point. So it's very easy for us to write the equation of tangent, a little bit SAT coming back in. So we know that the equation of tangent as per the point slope form is given by y minus y1 equal to m times x minus x1. So this is going to look like y1 is the y coordinate, which is clearly 5. M is the slope, which is 35 over 4. And x1 is right over here, that's 0. So y minus 5 is equal to 35x over 4, and they need the value at a specific value of x, or I mean t. So t and x are equivalent. That is the independent function. So t equal to 2. So all we got to do is plug in the value of t as 2 or x as 2, which is right over here. Calculator is not allowed, of course. So let's reduce this. 2 times 2 is 4, and 35 over 2 is 17.5, and adding 5 both the sides, we have the value of y as 22.5. And what is y? Y is after all nothing but m, so this means that the value of m of 2, that is the temperature of the milk at 2 minutes, is actually equal to 22.5 degree Celsius. Units are important, so degree Celsius, that is our final answer for part B of this question. I hope it makes sense. Let's move ahead and try the next part. Here they are asking us the value of the second derivative of m with respect to t, and use this guy to determine whether the approximation of the last question is an underestimation or an overestimation for the value of m2. So we should know this, that whenever you draw a tangent line anywhere, and there can be two situations, either the function is concave down or the function is concave up. Let me make concave up first, like this or like this. So let's say you're drawing a tangent at some point, and it's intuitive that if you draw a tangent at a point where the function is concave up, obviously the the value at the tangent is here and the actual value is here. So you are underestimating, right? You're giving an underestimation of it. So for a concave up function, you basically give an underestimation, and likewise for the concave down function, obviously your tangent's value is right here and the functional's value is right here. So you're giving a higher value, you're overshooting it. So it's an overestimation. So if we get the value of d square m over dt square as negative, that's concave down. So accordingly, we can answer this question. So all what matters is to find the double derivative of this guy. So let me just go ahead and do d over dt of this thing. So that's going to be d over dt of 1/4 of 40 minus m, correct? Be careful over here. Why? Because I'll tell you in a minute. 1/4 comes out d over dt of 40 minus m. So 1/4 remains as it is. What is the derivative of 40? 0. And what is the derivative of m? Remember, that's not 1. Because that is a derivative with respect to t, we got to find the derivative with respect to t. So that is just dm over dt. Right, this is what we have to be careful about. So this is negative 1/4 of dm over dt. That's what we have. Running a little short in space. Let me separate my work over here. I hope I can do in this much space. Okay. And what is dm over dt, by the way? That is already given in the question, right here. This is dm over dt, so I'm going to plug that back in over here. So it's going to look like 1/4 of 40 minus m, and 1/4 times 1/4 is 1/16 along with a negative sign outside. So that's going to look like negative 1 over 16 times 40 minus m. Remember, it was already given in the question. I'm just going to go back to the original, the initial information of the question. I've already highlighted that the value of m is always less than 40. If it is always less than 40, can we say that this guy is always positive? 1 over 16 is positive. Positive times positive is positive. And this negative is going to make everything negative. So can we say, write an expression? So by the way, this is the expression first. I'm going to box it up. And then they want us to use this. So we clearly, I think you know what I'm going to say now, that d square m over dt square is less than 0, which implies that the function is concave down. And courtesy to the green part, which we already did earlier, concave down means it's an overestimation. So overestimation, what we estimated in part B is actually an overestimation of the actual value of m2, right? It's an important question. This concept in itself is quite important, so please make sure you understand this. I think this is the last part. Yeah. So use the separation of variables to find the expression for mt. Okay, the particular solution. Okay, all right, this is just the solution of the differential equation, pretty easy differential equation, just the separation of variables. So dm over dt is going to be 1 over 440 minus m. I'm going to rearrange or redecorate this a little bit, bring all the family members of m on one side and t over on the other side. I'm going to do that in steps so that you can follow. Multiplying 4 both the sides, so 4 dm over dt is going to look like 40 minus m. I'm gonna multiply both sides with dt so that dt goes over on the other side. And last but not least is obviously dividing both sides with 40 minus m so that all the family members of m are on one side and t is on the other side. And all I have to do is integrate or find the antiderivative on both the sides over here. All right, excellent. So let's move ahead over here. Let me separate my work. So what is the integration of 1 over 40 minus m? If you cannot figure out right away, obviously that's going to be log. But if you think you are getting a little bit confused, use a u substitution. It doesn't harm. So 4 minus m is u, which means that minus of dm is du, which means that the value of dm is negative of du. So the left side integration is going to look like 4 times dm will be replaced by negative of du over 40 minus m is just u, and dt is just dt. So this is going to look like negative 4, and what is the integration of 1 over u? That's natural log of absolute value of u, and that is equal to t plus some constant of integral c. Obviously I want my answer to be in terms of original variable, so I'm going to plug u back in as 40 minus m. So that's going to look like absolute value of 40 minus m is equal to t plus c. Okay, but I need c as well because the initial condition is already given to us. All right, running a little short on space once again, so I hope I can do this in this space. Okay, so it's already given that at t equal to 0, m is 5, because that is the meaning of m0 equal to 5, right? That when t is 0, m is 5. So I'm going to plug that back in over here, over here to get the value of c. This is going to look like negative 4 ln of 40 minus 5, which is 35, and absolute value of 35 is just 35. So I'm not going to write absolute value. Is 0 plus c because t is 0. So the value of c is negative 4 ln of 35. So all we have to do is plug the c back in over here to get the value of m. So that's going to look like negative 4 ln, let's change the colors, shall we? Negative 4 ln 40 minus m is equal to t minus 4 ln 35, but do not leave the answer like this because they need the expression of mt. So they want you to isolate m entirely. So I'm going to erase this part over here. I hope you have written this down if you were writing anything. So I'm going to rewrite that because that's going to look like negative 4 ln of absolute value of 40 minus m. And don't you think absolute value can be dropped? Why? Because like we said, m is always less than 40. So 40 minus m is always going to be positive. So I'm just going to drop the absolute value sign now. So that's going to look like 40 minus m is equal to t minus 4 ln 35. I'm going to add 4 ln 35 over on both the sides. So that's going to look like 4 ln 35 minus 4 ln 40 minus m is t. I'm going to divide both sides with 4, or maybe take 4 as a common factor. So 4 ln 35 minus ln 40 minus m is equal to t. I'm going to divide both sides with 4. So ln 35 minus ln of 40 minus m is equal to t over 4. I'm going to multiply negative on both the sides. I'm doing that for a reason. Ln of 40 minus m minus ln of 35 is equal to negative 3 over 4. And log a minus log b is log a over b, right? So I'm going to write this as ln of 40 minus m over 35 is equal to negative t over 4. All right, going to make some more space over here. So let me clear this part. Okay, So, okay, how to take anti-log both the sides? We just keep the inside guy as it is. So 40 minus m over 35 remains as it is. And the other guy is just raised to the power of e. So this is e raised to negative t over 4. Multiplying 35 both the sides. So we have 40 minus m is equal to 35 times e raised to negative t over 4. And finally, if we rearrange, the value of 40 minus 35 e raised to negative t over 4 is going to be m. Finally, the factor of m of t is 40 minus 35 e raised to negative t over 4. I hope I have not made any calculation mistake. Let me know what you think about this. If you're getting a different answer, please let me know in the comment section. So using the separation of variables, I find the expression for m of t, a particular solution, keeping in mind that m of 0 is 5. Talk about FRQ 4 2023 AP Calculus BC exam. This is one of the easiest question in the complete paper, in the complete exam, except the last part. The last part is a little tricky, but rest are really straightforward. Okay, it's all about interpretation. We have to keep in mind that, okay, let me read out the question. The function f is defined in the closed interval negative 2 to 8 and satisfies f of 2 is 1. And this graph is not of f, it's of f prime, right? That's what we have to keep in mind. The derivative of f consists of two line segments and a semicircle as shown over here. All right, there are two line segments, one semicircle, fine. Does f have a relative maxima, relative minima or maxima, or neither at 6? Give reason to your answer. Let's ask ourselves before even looking to the graph, when can a function have a relative minima or maxima? When f prime 6 is a 0 or undefined value. In other words, when that x equal to 6 is a critical point, given that f6 exists. So if 6 is a critical point, and very important, f prime x changes its sign. Now here it's very clear that although f prime 6 is definitely 0, I can see that f prime 6 is 0, it's just touching the x-axis. But it's not changing sign, it's just going from positive to positive, right? It's above the x-axis, so it's positive, and before 6, positive after 6, so it's not changing sign. So it's a critical point, but it is neither a max, neither a minimum, nor a maximum, because it's not changing its sign. So we're going to say it's neither, since this is not happening over here. This is not changing its sign. All right, pretty straightforward. Next question, on what open intervals, if any, of the is the graph of f concave down? Let's ask ourselves, when is the graph of the function concave down? When its double derivative is negative or less than 0. What is the meaning of this with respect to f prime? If f double prime is negative, don't you think it means that f prime x is decreasing? The other way around will be easy to understand. If a function, let's forget about the primes, if a function is increasing, what is the condition? F prime is positive. If a function is decreasing, what is the condition? F prime is negative, right? So I'm going to write this over here, and we're going to draw an analogy. If f prime is positive, it means that the function is increasing. If f prime is negative, it means that the function is decreasing. So if f is a new function, let's say g prime. So if this is g prime, obviously this will be its derivative, which is g double prime. So can we say that if g double prime is negative, g prime is decreasing? And that is exactly what is happening over here. That it's a vice versa. It's going from actually no, it's the same way. If g double prime is negative, so you know the function's double derivative is negative, it means that g prime is decreasing in nature, right? G prime is decreasing in nature. This means that f prime is decreasing in nature, right? And when is f prime decreasing? That's pretty straightforward. Over on this interval, oops, and on this interval. This is where the f prime is decreasing. So the value of x is from -2 to 0 union 4 to 6. If you don't like the union thing, the union way of writing it, or you can write the in the inequality form, it's -2 to 0 and 4 to 5. Sorry, 4 to 6. Oops, I wrote 5 over here. There should be 6. 4 to 6. All right, makes sense. Excellent. Let's move ahead. Find the value of this so-called limit or show that it does not exist, justify your answer. So the best way to find the limit is first we always check that direct substitution is working or not. So I just plug 2 in the function and see what am I getting. So I'm getting 6 times f of 2 minus 3 times 2. What is 3 times 2? 6. That's correct. 2 square, what is 2 square? 4. That's right. What is 5 times 2? That is 10. And plus 6 remains as it is. What is f of 2? I think that's given on the question. There you go. I will highlight. F of 2 is 1. So if f of 2 is 1, this means that I'm going to place f of 2 as 1. 1 times 6 is, yeah, and 6 minus 6 is 0. So, and 6 plus 4 is 10, 10 minus 10 is 0. So that's a 0 over 0, which is an indeterminate form. And remember a very great, very important, very effective rule, let's call it method, which we can use to evaluate the 0 over 0 or infinity form. That is a L'Hopital's. So I'm going to use L'Hopital over here. What L'Hopital suggests is you find the derivative of the top and the bottom separately till the indeterminate form is ruled out. So I'm going to find the derivative of 6fx first, which is just going to be 6f prime x, and the derivative of 3x is just going to be 3. The derivative of x square is going to be 2x. The derivative of 5x is just going to be 5, and the derivative of 6 is just going to be 0. And now I'm gonna sub in 2 and let's see if we are getting a meaningful answer. So it's 6 times f prime 2 minus 3 over 2 times 2 is 4 and 4 minus 5 is -1. So I'm gonna get -1 over here. What is f prime 2? That's very easy. I have the entire graph of f prime in front of me, and f prime of 2, where is 2? 2 is here. So f prime 2 is 0. 0 times 6 is, yeah, 0. 0 minus 3 is -3. -3 over -1 is 3, because both negative and negative will just cancel. So -3 over -1 is just 3, which is the final answer of this question. Yeah. I think this is the last part, yes. What is the absolute minimum? Okay, so this is a little challenging. There is a long way to solve this question as well, which some people have done. But I'm going to tell you a really conceptual way in which you can, just by analyzing the curve, it's a more analytical than doing more work, but it's a perfectly legit method. Find the absolute minimum of f in the closed interval of -2 to 8. Okay. Can we highlight the intervals where f prime is positive? So f prime is positive here, f prime is positive here, and f prime is also positive over here. Okay. Can we mark the critical points? The critical points are -1. The critical points are, another critical point is 2 and another critical point is 6. We already know that at 6 we have neither max nor min. So this is the neither case. At -1, I have the f prime changing from positive to negative. So that's the relative max. And at 2, it is changing from negative to positive. So that's going to be relative min. I'm interested in absolute min. So obviously, absolute min would be at the points either of local min or relative min or the extremas. So the relative max and neither are just ruled out. It cannot happen at these points. And then at the terminal. So terminal is just either -2 or it should be 8. All right. Now, the yellow part are the parts where f prime is positive. And what happens to f if f prime is positive? F prime is positive. Don't you think it means that f is increasing in nature? Okay. I'm going to draw a rough sketch of function f. I do not know from where it starts. I have no idea from where it starts. Let's say it starts somewhere from here. And I'm going to draw it from -2. I'm sorry. I'm going to draw it from -2. Negative. I do not know from where it starts. Maybe it starts from here. It's not going to change your answer. So I know that the yellow part is where the function is increasing, correct? I don't know how the function is increasing, maybe in a straight line, maybe in a curve. I don't really care, but we can figure it out, but it's not required. Maybe the function is increasing and it becomes still -1. It is increasing and maybe it becomes something like this. Okay. All right. Now the green portions are where the function is decreasing continuously, because the f prime is negative, right? F prime is negative, and whenever the f prime is negative, we very well know that the function decreases. So if f prime is less than 0, the function is going to decrease over there. So from -1, the function is going to take a detour and gonna go down and down. Obviously there will be a smooth turn over here because the derivative exists. So it's going to be a smooth turn and the function just decreases, going down, maybe somewhere till 0.2. I do not know how down it goes. I don't really care, but maybe somewhere at 2 it stops. Now again is the yellow region. So for the complete entire duration, the function keeps on increasing. Maybe it increases like this. Maybe it increases just for this portion. I don't care. Maybe it increases like this and ends over here. But what I care about is they need the minimum value. Don't you think the minimum value is actually at -2? Because that is the only point till which the function is decreasing. Till rest all the points, for all the duration, in fact the complete duration, remaining duration, the function is increasing. It cannot be minimum or lower than 2. So the answer is f of 2 without even finding anything. It's already given in the question that the value of f of 2 is 1. So its absolute minimum is 1. So its absolute minimum is 1. Absolute minimum is equal to 1 without doing all that antiderivatives or definite integrals, right? This is a perfectly valid method. I hope you understand this. Let me know if you have any confusion. Next FRQ 5 of AP Calculus BC 2023 exam. Okay, this is based on integrals, so something related with areas and all. We are given the graph of the function f and g as shown over here from 0 to 3. It is known that the equation of g is given as 12 over 3 plus x for x greater than or equal to 0, and it is a twice differentiable function. F is also given. We are not given the explicitly what f is, so equation of f is not given. But it satisfies f3 equal to 2 and its integral from 0 to 3 is 10. That is given in the question. So they are asking us to find the area of the shaded region enclosed by the graphs of f and g. Okay, that's pretty straightforward because the area which is enclosed between two functions is just given by the integration of whatever the bounds of x are. So in this case it is from 0 to 3 because clearly it's shaded and we can see that the functions are bounded between, you know, the values of x are obviously from 0 to 3. Upper function minus lower function, that's it. So upper function is f of x and the lower function is g of x dx. That's going to be our answer. This can be broken down, of course. So this is going to look like 0 to 3 of f of x dx minus 0 to 3 of g of x dx. I'm going to continue my work over here. Okay, this is already given. Fortunately, they have given the value of 0 to 3 of f x dx as 10. So I'm going to sub that in as 10. And the equation of g is also given to us, which is 12 over 3 plus x dx. Okay, a little bit of effort required over here. 12 comes out, and this becomes integration from 0 to 3 of 1 over 3 plus x dx. What is the antiderivative of 1 over 3 plus x? Natural log. So ln of absolute value of 3 plus x within the limits of 0 to 3. This is going to look like 10 minus 12. I'm going to place a parentheses because that's going to be the upper limit minus lower limit. So that's going to be ln of upper limit. What is 3 plus 3? 3 plus 3 is 6. So that's going to be ln of 6 minus ln of the lower limit. So 3 plus 0 is also, 3 plus 0 is 3. So that is ln 6 minus ln of 3. Since the calculator is not allowed, you can either leave the answer like this, or if you want to maybe simplify one step more, we can do that. Let me try to make some space for, myself. So this is going to look like 10 minus 12 times. What is log a minus log b? That is log of a over b. So that's going to look like log of 6 over 3. And what is 6 over 3? That is 2. So 10 minus 12 ln of 2. That is the final answer. Ln 2, if you know the approximate value, feel free, but I would recommend that just leave it like that because the calculator is not allowed. So why bother? Okay. Next question, evaluate the improper integral, interesting, of gx squared dx or show that the integral diverges. Okay, we can do that. Fortunately, the value of g, the function g is already given to us. So I'm going to say that integration from 0 to infinity. But how do we write the improper integral? We just replace the infinity with whatever alphabet you like. I'm going to replace that with a. Or maybe b. Usually the upper thing is b and the lower thing is a. So just following the custom. And the limit, we're going to place the limit of b approaching infinity. And gx square, so gx square is going to be 12 over 3 plus x whole square dx. Yeah. Okay. So limit b is approaching infinity, 0 to b. What is 12 square? 144. And the guy on the denominator is just 3 plus x, so that's 3 plus x whole square dx. I'm going to continue over here. 144 is an innocent constant that's going to come out. That's not going to interfere with my limit or integral anyway. So this is limit of b approaching infinity, 0 to b of, and at the same time I'm going to manipulate this. Can I move this on the top? I don't like this in the bottom. I'm going to move this on the top, so it's going to look like 3 plus x raised to negative 2 dx, right? Some basic rules of exponent. And why is this helpful for us? Because now I can apply, I'm not doing anything special, I'm just rewriting everything. Over here I can now apply the law of, the exponential rule, the power rule of the integration. So we're going to add the power with 1 and you're going to divide it with the power. So that's going to look like 3 plus x raised to negative 2 plus 1, which is negative 1, over negative 1 within the limits of 0 to b. I hope you're able to follow. Again, this negative sign, I'm just going to pull it out. I don't like that inside. So negative 144, limit still remains intact of b approaching infinity. The upper limit is going to be 3 plus b raised to minus 1 minus the lower limit of x is 0. If x is 0, then 3 plus 0 is 3, and I'm just left with 3 raised to negative 1. Too many negative powers. I don't really like this. Okay, I'm just going to make some space for myself and continue over here. So this is going to look like negative 144. I'm just going to redecorate this a little bit. At least I will try to redecorate. Negative 144, limit b is approaching infinity. Power of negative 1 means you got to take a reciprocal of it. So 1 over 3 plus b minus 1 over 3. Okay, and finally now I'm going to place the limit. So if b is approaching infinity, then infinity plus 3 is infinity, and 1 over infinity is 0. So this is going to look like negative 144, there's the 1, 0, negative minus 1 over 3, and finally I'm going to change my color to write the final answer as negative 144 times negative 1 over 3, which is 144 divided by 3. 4 times 4 is 8, 9. Wow, this is divisible, right? 3 times 4 is 12. And 3 times 8 is 24. So the answer is 48. Have they given the unit? Not really. Okay. That is the answer. Correct. 48 is the final answer. I hope that is correct. I hope I have not made any calculation mistake. I think I have not. All right, let's move ahead to part number C. That is the last question. Yes, that is the last question. I mean, the last part of this question. I'm going to make some space for myself. I'm just going to decrease the image of these two, size of these two images. Okay, I think that's legible. Okay. So what I am going to do is I'm going to read the question that h be a function defined by x times f prime x. Oh my goodness. Find the value of 0 to 3 of hx gx. This was a little complicated in this question. I think the rest two were okay, but this was a little complicated because here you got to use the integration by parts. So first thing, why it's complicated, because sometimes it's important for in her mind to click that okay, we got to use integration by parts in this case. So we got to find 0 3 of hx dx, where hx is x f prime x dx. The question is, what is u and what is v? Do you think? I think u should be something, and I think dv should be something which can be easily integrated. So, I mean, you might argue that, hey, we can integrate x as well. It's just x square over 2. We know that. Okay, fine. But if you take this as dv and this as u, you have to integrate this once again, and you have no idea what f double prime is. So it's not a great idea to take that as u. The other way around would work better, I would say. So this is u, this is dv. Right, that's going to work better. So the what is integration of part tells us that this will be u times v minus integration of du over I mean u prime and v, and then just dx. That's what it says, right? Okay. If v is already given to us, sorry, it's not given to us. We know the dv, so I'm just going to write here. dv is equal to f prime x, so obviously v is going to be fx. And u is x, so u prime is just 1, right? Yes. Okay, so u is, what is u? U is x, okay. U is x, and v is, what is v? V is fx, okay. So x times fx minus u prime. What is u prime? That's 1. And v, what is v? V is fx. Okay. Dx, excellent. And remember that it's not an indefinite integral, it's a definite integral. So this is already integrated. You got to place the limits of bounds as in from 0 to 3, and this is also from 0 to 3. Fortunately, we know the value of, I mean, I'm just going to write one more step so that it's, we all are on the same page. There's no confusion. So this is from 0 to 3 minus integration from 0 to 3 of fx dx. And in the question, there you go, 0 to 3 of fx dx is already given to us. So I'm going to place, I don't like that line, I'm going to use a proper line. I'm going to make a proper line. Okay, that looks like a proper line. Okay, so the upper limit is going to be 3 times f of 3, right? Yeah, 3, upper limit is 3 times f of 3 minus the lower limit is 0 times f of 0. Why am I overlighting f of 0? 0 times f of 0 is 0. Okay, anyway, I've written that. Minus 0 to 3 of fx dx is 10, like I said. Whoa, there you go. All right. F of 3 is already given. Yay, it's 2. Minus 0 times f 0 is 0, minus 10. 3 times 2 is 6. 6 minus 10 is, you need a calculator for that? No, it's negative 4. That should be our final answer. So there's integration of 0 to 3 of x f prime x dx using integration by parts, which is a little complicated, but I hope that makes sense. Right, so this is all for this FRQ number 5. I hope the video was helpful, and if it was, please subscribe to my channel. Bye-bye. Hi, my name is Darshan, and I'm an online tutor of math and physics. This is FRQ number 6, AP Calculus BC 2023 exam based on oops, this is the mic. Based on Taylor polynomial and the Lagrange multipliers. So over here, let's read this question out. Remember, this is important. They always ask one of the FRQ based on this question. This topic, I mean. Find f. Okay, the function f has derivatives of all orders for all real numbers. So let's define it. It's known that f0 is 2, f prime 0 is 3, f double prime x is, oh my goodness, negative f of x squared, f triple prime x is negative 2x, f prime x squared, Jesus. Find f raised to 4x, then that is find the fourth derivative of the function with respect to x, and write the fourth degree Taylor polynomial for f about x. Okay, x equal to 0, that's a relief. Show the work that leads to your answer. Okay, let's work on f fourth x, the fourth derivative of x. Obviously, I'm going to start my journey with the third derivative, which is already given in the question as negative 2x f prime of x square. And I'm going to take the derivative on both the sides, and 1, 2, 3, 4, or you can write 4 as a number. Of course, negative 2 comes out because that's a constant. I'm going to write d over dx of x times f prime x square. Why I'm writing like this? Because you have to use the product rule. So the product rule says that first term as it is, you find the derivative of the second term, plus the second term is as it is, you find the derivative of x. And what is the derivative of x with respect to x? That's 1. You're right. This is going to look like negative 2 times x, or what is the derivative of f prime x square? A little bit of chain rule is helpful over here. The derivative of f prime is just f double prime, and x square remains as it is. However, you need to go inside and you have to find the derivative of this x square as well, which is 2x. Plus f prime x square remains as it is. Let's open everything up and write in a single expression without the parentheses, which is negative 2x, not negative 2x, right? Okay, I'm going to write two more steps, one more step as in negative 2 and 2x times x is just 2x square f double prime x square plus f prime x square. And let me separate my work. Okay, and now I'm gonna ram this negative 2 inside, so that's gonna look like negative 4x square f double prime x square minus 2 f prime x square. That is the value of the, that is the expression rather for the fourth derivative of the function. I'm gonna keep this with me because I will be using this. As we are not done yet, we need to find a fourth degree Taylor polynomial as well about x equal to 0. So obviously I need f0, f prime 0, f double prime 0, f0, f prime 0, double prime 0, triple prime 0, and 4 prime 0, all the primes at 0. So let's find that first and then we'll write. It will be easy to keep a track, you know. Yeah. What is f of 0? Well, it's already given in the question. Very good. That's 2. What is f prime 0? That's also given in the question. Excellent. Why don't they give everything in the question? F double prime 0. What is f double prime 0? We gotta use this one. So f double prime 0 will be minus of f of 0 square, and 0 square is, oh my goodness, that's 0. So this is negative f of 0, and what is f of 0? That's 2. So minus of f of 0 will be minus 2. F triple prime 0 is going to be, I'm going to put 0. I'm not going to calculate this because that's just 0 multiplied with f prime 0. I don't really care what f prime 0 is because 0 times that is just 0. And the fourth derivative, 1, 2, 3, 4, 0 is going to be, this is 0. Okay, I like this. Why? Because x is 0, so 0 times the same story, 0. And this will become just negative 2f prime 0 or 0 square, if you mind if I write 0. 0 square is 0, and yeah, it's negative 2 f prime 0. Just getting a little lost for a moment, but yeah, f prime 0 is 3 and negative 2 times 3 is negative 6. Whew. So we have all the zeros written over here for the fourth degree. Of course, you know what I'm going to do. I'm going to erase everything because I need more space. And now we are all set. So the function f is approximately given by f of 0 plus f prime 0 over factorial 1 times x Why x? Because I'm finding about 0, so I don't really care about x minus 0 or whatever, it's just x. Plus f double prime 0 over factorial 2x square plus f triple prime 0 over factorial 3x cube. Right on the next line, f fourth derivative of 0 over 4 factorial x raised to 4. And this is where we need to stop because they are asking for 4th degree. Fortunately, we have the values of everything written over on the right blue. So this is 2, this is 3, 1 factorial is just 1, so that's just 3x. F double prime 0 is negative 2, 2 factorial is just 2. F triple prime 0 is 0, excellent, so I'm not bothered about these terms, it's just 0 times everything is 0, 0 thing. And this is negative 6, and 4 factorial is 4 times 3, 3 times 2, 4 times 3 is 12, 12 times 2 is 24, 24 x raised to 4. Finally, its value comes out as 2 plus 3x. Negative 2 over 2 is just negative 1, so that's negative x square. And 6 times 4 is 24, so that's negative 1/4 of x raised to 4. I hope this is the correct answer. Let me know what you think about this in the comment section. So this is the approximate function f using the Taylor polynomial. Okay. Next question is Lagrange error, very popular. Okay, the 4th degree polynomial f about x equal to 0 is used to approximate f of 0.1. It is given that its 5th derivative is always less than or equal to 15 for x bounded between 0 to 0.5. We need to use the Lagrange error bound to show that this approximation is within the 10 raised to 5 of the exact value of f of 0.1. Right, so we know that the Lagrange bound, first of all, what is the Lagrange bound? The value at f of some value at a is always less than equal to, as per the Lagrange bound, m times absolute value of x minus a raised to n plus 1. Rather than writing this as f of a, I'm going to write that it's error for the, in fact, the absolute value of, it's okay, yeah, it's absolute value, error at the 5th derivative. So error at the, yeah, it's absolute, the 4th degree polynomial. So error for the 4th degree polynomial, so I'm going to write this as error for the 4th degree polynomial, is less than or equal to m times absolute value of x minus a raised to n plus 1 over n plus 1 factorial. The most difficult part is to find the value of m, because m is the largest value of the 5th derivative, 5th as in just immediate next of what we are finding. So this is, we are finding 4, so that is 5th. 5th derivative's maximum value. Fortunately, it's already given to us that the 5th derivative's maximum value is 15, so the value of m is 15. So I'm going to replace m with 15, and x is 0, and the value of a at which we need to find is 0.1, because that's where we need to get the approximate value. N plus 1 will be 5 over 5 factorial. My goodness, that's too much. Calculator is not allowed. So 15 remains as it is. This just becomes 0.1 raised to 5. What is 5 factorial? It's 120, but if you don't remember these factorials till maybe 5 I remember till 5 factorial, but anyway, if you don't remember, we can always write it as 5 times 4 times 3 times 2, 2 times 1. 5 times 3 is 15, and 15 and 15 is gone. If you don't understand like this, 5 times 3 is 15, and 3 and 3 is gone. So I'm left with 4 times 3 is 12, correct? I'm left with 4 times 3 as 12. Oh, sorry, it's not 4 times 3, it's 4 times 2, right? 4 times 2 is 8. So we know that the error should be less than or equal to 1 over 8 times 0.1 raised to 5. What is 0.1? 0.1 is nothing but 1/10, so 1/10 raised to 5. So this should be less than or equal to 1/8 of 1/10 raised to 5. And 1/8 is a number which is less than 1. So if it is less than a number which is less than 10, 1 over 10 raised to 5, obviously it must be less than the other guy, as in 10 raised to 5 as well. That's what we need to prove, right? It's like saying if a number n is less than equal to 2. So obviously the number must be less than 3 on that page. So we are writing 10 raised to 5 because that's what they intend to, that's what they want us to prove, that it is within 1 over 10 raised to 5 of the exact value. So we know that the error is of course less than, in fact we are going to say it's less than 10 raised to 5, and in this way we actually have proved that the error is less than 1 over 10 raised to 5. So the Lagrange error is important. This is how we prove it. Hope this makes sense. And the last part on this is this. This is relatively easy. We are given the value of we are given a function g prime for color g prime, and we need to find a second degree Taylor polynomial for g about x equal to 0. So second degree means definitely that we need to go till g double prime, right? G double prime. So g0 is already given to us as 4. G prime 0 will just be this, which is e raised to 0 times f of 0. E raised to 0 is 1 and f of 0 is already given here as 2. So that's 1 times 2, which is obviously 2. And to find g double prime, we are going to just take the derivative once again of e raised to x fx. So g double prime is going to look like, that's going to be product rule, right? So e raised to x as it is, find the derivative of x, which is f prime, and then f as it is, and we need to find we find the derivative of e raised to x, which is e raised to x. So g double prime 0 is going to look like e raised to 0 times f prime of 0 plus f of 0 times e raised to 0. Let me separate my work over here, and this is going to look like e raised to 0 is 1, f prime 0 is, fortunately it's given as 3, plus f0 is 2 right here, and e raised to 0 is just 1. So 3 plus 2 is 5. We got the value of g double prime 0 as well. Let me actually box these up, otherwise it will be difficult to keep a track of these. So the Taylor of g is approximately g0 plus g prime 0 over 1 factorial x, why x, because again it's about x equal to 0, plus g double prime 0 over 2 factorial x square. g0 is 4, we have boxed everything. G prime 0 is 2, 1 factorial is 1, so it's 4 plus it's 4 plus 2x, and then the value of g double prime 0 is 5, and 2 factorial is just 2, so it's 5 over 2 x squared. This is the approximate function g, the approximate Taylor function g of second degree. So this is our final answer. Of course we can write in the standard form, writing x squared first and then 2x and then 4, but yeah, that's fine. So this is the last part of the last question of this exam. I hope this makes sense. Any questions, feel free to ask in the comment section, and if you like this video, please subscribe to my channel. Bye bye.